So we ended our last session on the example 6. Today we are going to continue with example number 7. Example 7 is the equation of a motion of particle is given by this equation, where S is measured in centimeter and T is in seconds. We have to find out the acceleration as a function of time, and we also have to find out the acceleration after 2 seconds. So, okay, let's start solving it. That is example number 7. We have given a distance function, which is S equals to 2t cube minus 5t square plus 3t plus 4. And we are asked to find out the acceleration, and we are asked to find out the acceleration after 2 seconds. So using the distance function, we have to first calculate the velocity, and then we can calculate the acceleration. So you have to memorize this thing, that ds over dt, when we differentiate the distance function, it yields a velocity function. When we differentiate the velocity function, it gives us the acceleration function. So what we have, okay, so what we are given a distance function. When we differentiate it with respect to time, because we have a variable t as a function, so we will be getting velocity, and then we differentiate the velocity, we will be getting the acceleration. So we will be doing this is how we will be doing our part A. Is it clear?
Yeah.
Okay, so let's quickly differentiate it to get the velocity. If we differentiate, let me just write it down. Okay, if you differentiate to t cube, what will be the answer? The same rules that we have studied yesterday will be used.
Okay, so it will be 2 into 3t square.
Okay,
so 60 square.
60 square. Okay, what about 5t square?
It will become 10t.
Okay, and what about 3t?
No, it's going to be 10t.
No, it's 3t.
Right. No, the one before it, 5t square, it will become 10t.
Yeah, I have written it minus 10t.
Or 20. Okay.
It's minus 10.
Okay.
Mm-hmm.
And this will become just 3.
Okay, and what about constant?
0.
Okay, so this is the velocity. If we differentiate the velocity, we will be getting the acceleration. Right?
Okay, so the first one is the distance, which was given in the question, right?
Mm-hmm. Yes.
Okay, and then we differentiate that, we got the velocity.
Yeah.
And then if we do it again, we'll get the acceleration.
Yes, if we differentiate the velocity function, we will be getting the acceleration. So the question can be asked in any way. You are being given the velocity function, you have asked to find the acceleration function, then you will be differentiating the velocity function. You have to just memorize this thing.
Can it be opposite, like they give us the velocity and then they want to find out distance?
Yeah, it can be, but for that we will be using the integration techniques, not the differentiation techniques.
Okay.
Yeah. So acceleration we will differentiate it again. So if we differentiate the velocity function, what it will be?
It will be 12t
12t
and then 10
minus 10, right?
minus 10, yeah, and then just 0.
Okay. So this is our part A is done. A of t we have got. Now we have to find out the acceleration at t equals to 2. What we'll be doing, we will be putting t equals to 2 in the function, in the acceleration function. So a of 2 equals to 12 2 minus 10. Is it clear?
Yes, it's gonna be just 14.
Yeah. And the unit is meter per second squared. So that's the unit of acceleration. Is it clear?
Yes.
Okay, let's check our answer. Oh, they asked the unit of s, I mean the distance was centimeter in the question that was given to us. So it will be centimeter per second squared. Okay, so that's the answer for question example number 7. Now let's move on to the other differentiation rules. The other differentiation rule is exponential functions. If we have the function like in the form of e raised to the power of x, e raised to the power of 2x, anything in the form of exponent like e, in the form of e. So which rules will be using to differentiate that function? Like this is the exponential function because we have 2 raised to the power x. The x is an exponent. This is the rule to differentiate the exponential function, natural exponential functions. The derivative of exponential function will be a function itself. The derivative of e raised to the power x, it's a function, it will be e raised to the power of x.
So it's the same thing?
Yes.
Okay.
Let's do examples on
So like if it was e to the power of 5, the derivative will be e to the power of 5?
Let me just explain it to you.
Okay.
The d of t, x of t of x will be e of x. Okay, if for example we have a function like in the form of e raised to the power of 2x, then what will be its derivative?
E to the power of 2x.
Yes, and then we have the differentiation of ex will be itself ex, but we have 2x. We have x, we have 2 with x, so we differentiate.
So it's gonna be,
Yeah, so we are going to differentiate 2x again. So the differentiation of e to x will be e to x, and then the differentiation of 2x will be 2. So the differentiation of e to x is 2e raised to the power 2x.
I got confused a little bit. Can you just do it again, please?
Yeah, sure. Let's take another example. Like we have e raised to the power 5x, and we have to take its derivative. So its derivative will be the derivative of e5x. So using this rule that the derivative of exponential function will be itself. Okay. So the derivative of exponential function is e5x will be itself, but we have a constant. Yeah, but we have a constant as well with x function. So we will be derivating it again. It will be the derivative 5 as a constant will come out, right? And then the derivative of dx over dx is itself is 1. So 5 e raised to the power 5x. Is it clear?
Yeah, okay.
Because
so 5. Okay, so we can just like let's say it's e to the power of 7x. We can just put 7e 7x, right?
Yes.
Okay. Understood.
Okay. So this was an example 8 on exponential function. The derivative of f of x is equals to ex minus x. They are differentiating the function here. Okay. So the derivative of ex is itself ex, which they have written here. And the derivative of x is 1. So the answer is ex minus 1. Is it clear?
Yes.
Okay.
Because x is a constant, right?
Which x? I mean, you mean this x?
Yeah.
We are differentiating the x with respect to x. So it is dx over dx. The derivative of a function with itself is 1.
It's 1. Yeah.
Because it's written a d over dx. So that's why.
Okay.
And yeah, in the question it was asked, find the first derivative and the second derivative. We can also, represent our derivative using this as well. F dash of x as well. F dash of x or d over gx. So double differentiating the function ex minus 1, ex will be itself ex, and the derivative of a constant is 0. So that's why we got only ex upon double differentiating the function. Is it clear?
Okay.
Is this example clear?
Yeah, the sign between the f and the x, this is the derivative sign, right?
Yes. Let me just go. Okay. Let me just write it down here as well. We can write our derivative f dash of x or d over gx. Both are the same thing. We can represent our double differentiate like this or like this. Both are the same. Both are the ways to represent our differentiation.
Okay. Let's do the example number 9. Let's leave the example number 9 for now. We'll be coming back because it's tangent and parallel, everything covered. So we'll be coming back. The most important rules, those are used in the differentiation, are product and quotient rules. Like these rules are mostly used rules in the derivatives. So the rule is this, the product rule. If you have two functions and the functions are multiplied, like two functions, f of x and g of x are the two functions, and we have to take its derivative. So what we'll be doing, this is the formula to derivative of function, to derivative of functions when two functions are multiplied together. So f of x will be as it is, and we'll be differentiating the second function, and then there will be plus sign, then g of x, and we will be differentiating the first function. Is this formula clear? I can say again, please.
I said when two functions are multiplied, like so far we have studied when two functions are added, what will be the rule? When two functions are subtracted, what will be the rule? Now, if the two functions are multiplied, what will be the rules? We will be using this formula. F of x and g of x are the two functions. Upon differentiation, f of x will be as it is. We will be we will be taking a derivative of g of x, and then there will be a plus sign of the formula, and then we will be keeping the g of x as it is, and we will be differentiating the first function, that was f of x. So this is the basic formula. Let's do example number 1 on the screen. It was x ex. X ex. The two functions are multiplied. This is the function. This is another function. Because we have x sign here, so we know that there are two functions.
Okay.
If you want to take its derivative, for example, this is f of x, and this is g of x. The formula is, let's not take it as f of x because the function is given in the f of x form. let's take it h of x. So the formula will be h of x will be as it is, and we'll be differentiating g dash of x. There will be a plus sign of the formula. Then we will be keeping g of x as it is, and we will be differentiating h of x. Is it clear?
Yeah, until now clear.
Okay. So h of x is x. We'll be keeping it as it is. We will be differentiating g of x, which is e of x. The differentiation of exponential function is itself exponential function, right?
Okay, yeah, itself. So it's gonna be ex.
Plus sign, and then g of
Plus
x.
sign. We take the original, or like, okay, let's say if it was e2x, we take the original or the new one.
In this g of x, we will be taking the original function, but if we have asked the derivative, then we will be differentiating e2 of x. It will be 2
Okay, so now it's going to be ex.
Yes. And then
okay, plus the derivative of x. I mean
hx, yeah. Hx is x, so the derivative of x is
1, I think.
1, yes.
Yeah, by itself.
Yes. So the x ex plus ex. We can simplify it. It's up to us that ex x plus 1. Is it clear? This is the derivative of function x ex.
Yeah, okay.
Okay.
How did we get ex x plus 1? Okay, because
we took a common. We took a ex common, and then what's left x, and here was left 1. So it's x plus 1 inside, and taking
understood.
Okay, let's do another example. Let's just continue it. Can we take its double derivative? We can write our double derivative like this: f double dash of x, right? So d over dx of ex. Again, the two functions are multiplied.
Yes. So first we're going to take the... Okay, so first we will leave ex by itself. Okay, so and then we're going to derive the second part.
Then we take the derivative of second part, then plus sign of the formula, right?
Yeah. So now we'll... So which one will we put? We will put x plus 1, right?
Yes. Now I have to keep x plus 1 as it is.
And then the derivative of the e of x. Okay, so e of x will be the same as it is. Okay, and then how do I derive x plus 1?
We have to take the derivative. Both the functions are added, so we have to take the derivative individually.
Okay, so it will be 1 and then 0.
Yes. There is a plus sign of the formula.
And then the same 1 plus 0. No,
we will be
same, right?
Yeah. And then the derivative of ex will be
same as ex.
Okay. So it will be ex plus x ex plus ex, right? X multiplied with this and multiplied with 1. So it will be 2e2x, 2ex plus xex. Ex and ex will be 2ex, and xex will come as it is. Is it clear? This is the double derivative.
There's one rule that we're supposed to know. It's like a square plus b square is like a b, like that.
Which rule you are talking about?
We took it in calculus, in pre-calculus. It's like a square plus b square is we take a and then ab and then plus b, like that. I don't remember exactly. Is this the one you used here?
No.
Okay, then never mind. Maybe I got confused.
No, that rule is not used. We just multiplied here and then we added whichever were the like terms, and this is the answer.
Understood. Yeah.
Okay. Is the rule clear to you? How we use it? How we use the product rule?
Yeah, this was clear.
Okay. And let's do another example. This will you try yourself. So f of x is e2x and x square. Can you do this one?
Okay, so we have to write the equation, which is f of x equals h of
Okay. No, this equation, right?
yeah, this one.
Okay, so let me just write it for you here. Plus g of x h dash of x. Okay, here you go. This is the formula, and try to solve this question. X squared multiplied with e2x.
Okay, so the first one, we will leave e2x as it is. So we write e2x. Okay, and then the derivative of x squared plus the derivative of e2x.
Okay.
Okay, plus x squared.
Plus x. Okay, okay.
Yeah. Okay, so we will leave this one as it is. X squared will become 1. No, it will become x. Right?
No.
Become 2x. Become
yes.
2x, yeah.
Yeah.
Okay, plus x squared as it is. Okay, plus 2e to the power of 2x.
Yes. Let's just simplify it. 2x e raised to the power 2x plus 2x squared e 2x. Right?
Just 1 second. E to the power of 2x. Okay, yeah, okay, and then, okay, yes.
And then just we can simplify it by taking its common. So 2x e2x is common. 1 is left inside. And then 2x, because 2x has taken common, so there will be left only x. e2x is also common. So this is the answer for e2x x square. Is it clear?
Yeah, okay, this one understood.
Okay. Again, they have did the same thing in example number 2. Like they have the function in the form of t. F of t is equals to square root t multiplied with a plus bt. So the same rule. There are two functions, square root t and a plus bt are the two functions. And then they use the product rule to get the answer. Should we solve it or?
Yeah, please.
Okay. So square root t a plus bt. This is the function that is given to us, and we have to find out the f dash of t. Okay. Again, this is the one function, this is another function, right? So f dash of t will be keeping this function as it is, square root t, and we'll be differentiate. Yeah.
We'll differentiate the second one, so it will become dx a plus bt.
Yes, and then there will be plus sign in the form.
Yeah, dx square root of t.
Okay.
Okay, plus no, I mean a plus bt as it is.
Okay.
Okay, so square root of t. The second step.
Oh, it's t. Square root t is equals to Now a and b are the constants here.
Okay, so it will become 0, both 0.
Mm-hmm.
All right, because derivative of a constant is 0.
Yeah, but dA over dt is 0. Okay, because the constant derivative is 0. There is a b constant, but we have t as well.
Okay.
The rule that we understood yesterday, it was taking constant out and then the differentiating the function. It was something like that. Taking b out and differentiating it with respect to t.
Okay, so the t will become 0 because over itself is 0. No, it will be 1.
Yes.
Yeah, over itself it will be 1, and so it will be only b.
Yes.
Yeah. Okay, plus a plus bt.
Mm-hmm.
And then I forgot how to differentiate square root.
It will be like this. Square root will be like this, 1 over 2. And then using the power rule, taking power and then
1 over 2.
And 1 over 2 minus 1. And then taking the derivative of a function, that is t. So it will be 1 over 2 t. Half minus 1 is minus half. And the derivative of a function with itself is 1. So it will be 1 over 2 square root t. Right?
Why square root t?
Because see, 1 over 2 and there is t half. But
yes,
with
okay.
but with the minus sign. So if we want to make it positive coefficient, we will be bringing it down. So t half, right?
Yeah.
And then t half is equals to square root t.
Yes, okay, clear.
Okay.
I just need more practice with this. Okay.
Yes, you have to just go through the yesterday session.
Okay, can you after I finish, let's say after we finish each session, how can I practice the thing we did? I don't want to repeat, because if I repeat only the things that I did with you in class, I will remember the answer. So I want to do new things. Where can I get from the book new examples?
There are exercises in the, because if we just complete the one topic, there are exercises in the book. Let me just show you after the session where are the exercises that you do.
Okay.
Okay, let me complete this question and then we get back to the book and then let me show you. So
okay.
f dash of t equals to square root of t, and 0 plus b is b plus a plus b t, and it would be 2 square root t. Is it clear?
Yes.
So this is basically the answer.
We don't have to go any further, right?
No, I don't think
okay.
So there is no need,
need
to simplify it. Yeah.
How do I know when I only do one time derivative or 2 times?
Are you talking
the question will ask?
Are you talking about the derivatives or?
Yeah, sometimes we do one times derivative and sometimes we do double derivative. So how do I know which one to do which?
It will be asked in the question that you have to differentiate it once, or you have to differentiate. You have to take the double derivative or the first derivative. It will be mentioned in the question.
Okay.
Okay, let's get back to the question. Is our answer somewhere different or what? Okay, it's the same. Okay. It's the same. They just have simplified our answer, like square root TB. And then I think they have taken the LCM or somewhat. They have simplified the answer further.
Okay.
We have done only this part, till this part. We haven't simplified it. Okay. There is another, method to solve the same question. If we multiply square a with if you multiply square root t with the whole function, okay, that's what they have done, then they don't need to apply the power product rule. They multiply the square root t with a, it will be a square root t, and then they multiply the square root t with bt, so it will be bt square root t. And here a is the constant, and then they just take the took the derivative of square root t, and bt square root t, they combined t and square root t and wrote t raised to the power 3 of t, and then they just took the derivative. So there was no need to use the product rule if we just multiply square root t with the whole function. Whichever way, you know, whenever the question was given to you, you just have to see that which rule is easier for you to use. If there is a simplification required, then you can make your function simpler and take the derivative. Not required, you think that you can't simplify it, then whichever rule, like the product rule, is applicable, then use the product rule.
Your voice is a little bit far.
Is it clear now?
Yeah.
Okay, I was telling you that you have to, whenever the function is given to you, you have to look at it, which rule is simpler for you to use over this function. Like in the example 2, there were 2 method or 2 rules were used to solve a single question. So probably there will be a question that there will be multiple rules you can use. So you have to think which rule you can use easier.
Okay, can you make an example of the second rule so I can have both?
Okay, let's do let's do it on the screen as well.
Which one do you think is better?
I think the solution 2 was a little easier, but you know, when you practice, both rules will be easier for you.
Okay, can you please do like 1 example or 2 examples of the second rule so I can get an idea?
Okay. So the function is f of t was square root t a plus bt. Okay. So in the first method, we just took the 2 functions, square root t and a plus bt. Okay. Now we are multiplying square root t with the whole function a plus bt. So it will be a square root t, right?
Okay.
And then there will be plus sign of the formula or of the function, and then multiplying b t with square root t, it will be like this. So a square root t plus b t, and we can write t like this, t half.
Okay, yeah, to get rid of the square root.
Yeah, but we have to, before that we have to simplify it. There is t1. When we know that when the base is same, we can add the powers, right?
Yeah.
So it will be 1 over 1 over 1 plus 1 half. It will be a t half plus b t raised to the power 3 by 3, right?
Why plus half? Why is not minus half?
Like here?
Yeah.
Because it is 1 and it's 1 half. If there's a minus sign like t minus half, then there will be minus sign. There isn't
So
any
because
minus
it
sign.
So because it's bt, the power over the t is square, right?
The power of t is the first t. The power of first t is 1.
No, the third line.
Sorry.
The third line, like the third one down, it's a square root of t. Yeah, this one plus bt, and this power over this t is how much square?
Is 1. This is 1.
1.
And this is
okay.
half.
And then the second t is half. So because they're the same t, we can add together.
Yes.
Okay. So it's gonna be 1 minus plus half.
Yes.
Okay.
And then when we add 1 plus half, it will be 3 by 2, right?
Yeah, 3 by 2.
Now we don't have to apply, like there aren't any functions that are multiplied. We can apply the simpler rules that we studied yesterday. A is constant. We'll be taking it out. We'll be taking the derivative of t half only. There is a plus sign in between. B is also constant. We'll be taking it out.
And then this derivative of t3 over 2.
Yes. Now using the power rule.
Yeah, so it's going to be it's gonna, we can do the same thing with fraction, like it's gonna be a 1/2t, and then the 1/2 minus half, so minus 1/2.
Yes.
Okay. Plus b, and then 3/2t minus 1. So it's gonna be 1/2.
So half a, we can write it like this: 2√2. Oh,
Mhm.
you can write it like square root t.
Okay.
Right? And then plus sign 3/2 b and square root t. Right?
Because minus half, right?
Because of minus half. Yes.
Okay.
Is it?
Okay, and this is the final answer.
This is the final answer. We can further simplify it as well because both are the same. So 2 square root t, and then it will be a plus 3b in the numerator. So this is the simplified answer.
Okay.
Is it clear?
Yes.
Okay. If we simplify our answer from the method 1, we can get the same answer. Should we do it?
Oh, yeah, if you think it's better, we should do it.
Okay. Hello.
Yes.
Am I audible?
I don't hear anything until now.
Okay. So what we have done, we just cross multiplied it. We cross multiplied square root t, b with 2 square root t, and a plus bt with 1. It will become a plus bt, and then we multiply the denominators. So it will be 2 square root t. Is it clear?
Yes, but how do you get 2 square root t and then square root tb?
This one?
Yes.
Multiply the 2 square root t with square root t with b. Cross multiply.
Okay, so we had similar denominator?
Yes. We actually have to take in the LCM by cross multiplying.
Can you do again, please? Because I didn't hear when you were saying.
Okay. Let me just write it down again. There's a plus sign between. We cross multiplied it, and it is square root b, square root t multiplied with b, and multiplied with 2 square root t, because we are just cross multiplying it. And there is a plus sign, and then a plus bt.
As it is, okay.
Okay, and then multiplying the denominators, which will become 2 square root t. Is it clear?
Okay, okay. Clear.
Now simplifying it. 2 square root t. 2 square root t will be t, right? T half.
Yeah, okay.
And t half. So
Plus t half, yeah.
and then we have b plus a plus bt, right? Okay, so 2bt plus bt, 2tb or 2bt is the same thing, right?
Okay.
So 2bt plus bt will be 3bt.
3bt plus a over 2 square root t.
Yes.
Okay.
Let me check if we got the same answer. Is there any other further simplification required? A plus 3b over 2 square root t. Why we have got an additional t here? What's the book on? Book answer is this one. And I think we have made the mistake in method number 2 somewhere. We missed out t. Let me just check it out. Hey, we made a mistake here. We subtract 3 over 2 with minus 1, it will be half. Once we minus half. Let me just correct it out. I'm sorry about it. So it will be a half a and square root t plus 3 over 2 b, and it is t half. It's not t minus half. So now taking the LCM, 2 square root t, and it will be a plus 3b square root t multiplied with square root t because we have 2 already here. So we just need to multiply square root t. We are just cross multiplying it. Okay. So it will be 2a and plus sign 3b square root t multiplied with 2 square root t divided by 4. You have to multiply that denominator. So it will be 2 multiplied with 2 square root t. Is it clear? 4 square root t. 2a plus 2 times 3 is 6. B and t half will be t, right?
T. Yes.
Okay. Now, can we take 2 common? A plus 3bt will be left inside. And we have 4 square root t in the bottom. 2 goes into 4 by 2 times. So it would be a 3bt divided by 2 square root t.
Okay.
Now we have got the same answer. I just made a mistake. I thought it's t minus half. And then the answer. Is it clear? Is it clear?
Yes.
Okay. There is another rule that is called a quotient rule. We'll be understanding this rule tomorrow.
Your voice is not clear, please.
There's another rule that is quotient rule. We'll be doing it tomorrow. So
Okay.
let's do the example, understand example number 3. Example number 3 is just important. Example number 3 is the function that is given to us. F of x is equals to square root x g of x, where we have given g of 4 and we are given g dash of 4, and we have to find out f dash of 4. Let's do it. F of x equals to square root x g of x, and we have given g of 4, which is 2, and we are given that g dash of 4 is equals to 3, and we have to find out f dash of 4. Okay, this is the data that is given to us. The function is f of x. Again, the function is multiplication of two functions. Square root x and g of x are the two different functions, right?
Yeah, so we can use the rule.
Yeah, power rule, I mean the multiplication rule, product rule. So
it's going to be square root of x plus d over dx d of x, and then plus d over d of x square root of x.
Okay.
Plus g of x.
Yeah.
Okay, and then
square root x will be as it is, and the derivative of g of x will be g dash of x, like this. If someone asks me, there is a function f of x, okay, and the function is 2x, for example, and someone asks me to find the derivative of f of x, so I write down like this, f dash of x, and whatever the derivative of function is 2, so the derivative of f of x is f dash of x. Now the derivative of g of x will be g dash of x.
g dash of x, yeah.
Yeah, the g of x can be any function that is not given to us. They have just
okay.
They have just given the values that we'll be using further to solve the question. Now there's a plus sign in between. The g of x will be as it is.
And then the derivative of square root of x.
It will be power first. And then
1 over 2x. And then negative 1 over 2.
Okay, negative 1 over 2. So let me just multiply the things and I'm getting g dash of x square root x plus half g of x, and I can write it like this, square root x, right? I just multiplied the things and arranged them like in a way that we can solve it further. Okay. Is this step clear?
Yes, until now clear, yes.
Okay. Now there's some information, additional information is given us. That is g of 4, g dash of 4, and f dash of 4. We have to find f dash of 4, not f dash of x. So there should be 4 instead of x, right? So we have to place 4, f dash of 4. Now wherever the x in the formula, there will be 4.
4.
So
okay, so it's going to be...
Yeah, g dash of 4 and square root of 4 plus half g of 4 and square root of 4, right? And g dash of 4, that we know that it's 3, right?
Okay.
I was talking about g dash of 4 that was given to us. So which is 3. We just substituted its value and then multiplied it square root 4. Then there's a plus sign, half square root 4 and g of 4. The value of g of 4 is 2, right?
So this is confusing, like every time the numbers change.
Which number?
Like it was g of x, and then g of x became 4, and then g of x, it was g4, and then it became 2.
You are talking about the last step, right?
Yeah.
So we just substituted 4 in the formula wherever it was x until this step, and then we know the value of g dash of 4.
Okay, so they simplified for us.
I didn't get the question. What you asked?
They simplified for us.
Yeah, they have given us that what is g dash of 4, because they haven't given us information about g of x. We don't know what's the function. Is it 2x? Is it x squared? It can be any function. So they have not given us any information. They have given us g of 4 and g dash of 4. And we know its value is 2 and 3. So g of 4 is 2. We just substituted g of 4 is 2 and g dash of 4, 4. Is it clear?
Yes.
G dash of 4 was 3, sorry. So it will be 3 and square root of 4 will be 2. 2. Square root of 4 will be 2. Multiplied with 2. 2 cancel out with 2. It will be 6 plus 1 over 2. And it will be 6.5, right?
Yeah.
Is this question clear? Is this question clear to you?
Yes.
Or we can write this 13 by
2. But 6.5 is enough, right?
Yeah, we can write 6.5 or 13 by 2, whichever way. Like,
okay.
Both are the answer. Both are the similar things. Whichever way you can write the answer. So is this question clear?
Yes.
Now let me get back to the book and show you the exercises. So we have got 6.5. From tomorrow's session, we will be continuing with question 2. There are exercises. Chapter number 3 and 3.1. Okay. This is the exercise for topic 1 that we studied yesterday. So you can practice from here some of the questions that you think that we have studied. Like the 3-32, you can do it. The questions. Can you see the book?
Yes.
Okay. These are all the questions that you can do it. They will be enough to practice the rules that we have studied yesterday. You can also
and today also?
Today, yeah, some of the rules today, because we were doing 3.2 today. So today's topic will be covered in exercise number 2. Yesterday topics will be covered in exercise number 3.1. And today's topic will be covered in 3.2 exercise.
3.1, 3.2.
Yesterday topics will be covered in 3.1 exercise. Today's
okay, and today will be
today some of the topics will be in 3.1, and then some of the topics will be in 3.2.
Okay.
If you do like these questions, the yesterday's rule will be enough, to revise.
Okay, tomorrow you will not have a class, right?
Tomorrow we have a class.
Saturday. Your voice is not clear.
I was saying that we can do the class tomorrow. Except Sunday, we can do like 6 days a week.
Okay.
So, yeah, it's okay for you.
Yes.
Let's end it here and meet you tomorrow at the same time, like 4 to 5, right?
Yes. Okay.